Robert.
Hey, how's it going?
Good. How are you?
All right, so I guess everything's working, the audio, the video.
I think so.
All right, great. Um, yeah, thanks for talking. I appreciate it. And
Yeah.
I started doing this, trying to find uh, people interested in this intersection between art and science and engineering, and I guess I call it STEAM, but it's hard to find too many. But then I think I'd forgotten about Cooper Union, but now it brought back, what I've heard about, I've seen some programs about the concept and the idea of it. Um, so we could probably talk about that some or whatever you want to talk about. Um, I guess just tell me a little about yourself or
Sure. So I'm Mili. I'm a professor of mathematics. My area is applied mathematics. My specialty is numerical linear algebra. So I've been working with the National Institute of Standards and Technology, NIST, with a lot of different types of problems related to robotics and engineering kind of applications. So I mix mathematics with engineering and computer science. So I've used mathematics to help with the evaluation of robotic arms with what's known as a mobile manipulator when you add a robotic arm on top of a mobile unit, kind of like a
okay.
remote control car,
Uh-huh.
as well as exoskeletons.
Oh wow.
And so it's been a lot of fun kind of creating or using mathematics for a field outside of maybe what's classically known as mathematics.
Yeah, more applied, I guess. Yeah.
Exactly, exactly. Since I've come to Cooper Union is a very interesting place. I'm housed in the engineering school, but we also have an architecture school and an art school. So I've been kind of really interested in collaborating with these other schools and trying to kind of come up with projects and ideas to combine mathematics, engineering, art, architecture. So it's been fun.
How long have you been there?
This is my third year.
Third year.
Yeah.
And came from Maryland before that. And
Loyola University, Maryland. Yep.
okay. Um, so, is it, I guess it's strongly encouraged for you to work with the architects and artists and at Cooper Union, right?
Yeah. Yeah. There's been a strong emphasis in trying to kind of bridge programs between our three schools, and so this is something that I've been, really, really interested in, I'm kind of excited about where this is going to go. So, yeah, I have a couple of projects that we're just starting this year, so we'll see how that progresses.
Okay. And are there any other projects you'd like to talk about from I tried to find some background information, and I saw something where you're doing predator prey with differential equations. Maybe that was longer ago.
Yeah, that was a while ago. Yeah.
Groundwater. But I saw the robotics.
Hmm.
Are robotics being used, I guess, in more artistic?
Yeah, there's quite a bit. And this is kind of one of the projects that I'm interested in. I have a group of students right now that are building body tracking algorithms so that you can, follow your hand as it's moving around and being able to figure out 3D positional information about that. And so one of the projects that I'm interested in doing is using this type of information and working with some artists and figuring out a way that we can collaborate on this. So maybe we could do something with performance art and modeling the motions. And so specifically one of the projects I'm interested in is this kind of interplay between motion and perception, and how artists may be able to use this. And moreover, how maybe their interpretation could influence the way we build algorithms. So it's not necessarily that we're only trying to provide an algorithm, but instead like using their ideas to kind of adapt our algorithms. And so this is something that I'm really, really, really excited about. We have another project with architecture where we're going to be working with the idea of domestic robots and understanding how that influences our space. And so this is one of my students led this kind of is leading this project, and that's been really fun. We're working with a group of architects, an architecture professor, and just understanding space and kind of having a different way of looking at this problem, and asking different questions and what may be technically asked from an engineer or a mathematician's point of view. So
Yeah, that kind
so
of,
it's been really fun.
what I think is interesting is when one person who's thinking about things a certain way, and another person thinking about a different way, and then you overlap. That's where like more interesting things happen. And you're mentioning the motion, so I was envisioning, like musicians say, and that they have very fine motions probably to play an instrument properly, and trying to have a robot do that, I could see as being a very difficult task.
Yeah, it's incredibly difficult. Like the first years I was at Cooper, I was co-teaching an industrial robotics course. And so one of the groups had a robotic arm. You basically type, the keys, and it was just kind of trying to press the keys to kind of copy the motions
Right.
or whatnot. And it was just really kind of fun to see. I mean, it's hard. You think about all the steps that go from us seeing a note and comprehending it and then sending signals to actually locate a piano, for instance, and then playing it, right? So that's just the mechanical like kind of structure of it. But then to give it emotion, to give it depth, to give it soul, like that's another aspect of that. How do you program that, right? So I think it's a really fascinating area to think about. You can do something algorithmically, but is there more to it? And so I find it to be really, really interesting.
Yeah, I was just thinking, you brought some other thoughts. I was watching, watched Westworld?
I
This
haven't
show.
watched it, but I've heard of it. Yeah.
Anyway, it's kind of dark, but at the beginning, they have this sequence where they're printing like I guess robots, but they look like humans, and it has I don't know, I forget what they call it, but the piano that they used to have those pianos that had this paper they went through with holes. It taught it to, or told it which notes to play. And it's doing that, but it has the artificial hands playing it.
Mm-hmm.
So it's kind of touching on some of that. How do there's a lot of nuance, I think, and how hard it presses and how it doesn't. And but also I was thinking about surgery. There's probably some similarities. Maybe stuff you do with this could improve. There's doing a good surgery, making the right incisions and everything is probably very difficult too. So
I'm very much interested right now in hands. So it's another kind of project that I'm starting to delve into. It's just the motions and what's necessary. And if you look at the mechanics of just your hand, it's a very, very complicated um, structure. I mean, to model the thumb itself, I don't think there's been a lot of models, but to accurately model all the motions and the range is really a very complicated and complicated kind of task. And then to build something to model that is in itself really, really challenging. And I have a group of students that are interested in this problem, and I think it's really fascinating. And then to maybe have a hand that you build mimic your own motions. I think that it's a very challenging and yet very interesting problem. And hands are, by nature so artistic and so beautiful, and they can convey such emotion. And so how do you do that? And so that's another kind of side that I've I've been really kind of fascinated by and
So do you
interested
try
in.
to make, or I don't know if you're making robots, but do you try to make them look more human or make them just more functional?
And these are the kinds of questions that you ask, right? So should they be functional? Should they be expressive? You know, the materials that you use, the aesthetics that you create, you can build it a mechanical kind of structure, but then depending on what you put over it and what you see can have
Yeah.
very different kinds of emotions, right? So if you were to see like a Terminator hand versus something that was, I don't know, like ribbons or something where it's flowing and it's just really
Mhm.
beautiful, that just from aesthetics gives a completely different feeling for the user who's looking at it, right?
Yeah,
So
that's really interesting. Um, I mean, I don't know, maybe someone's already doing this, but I think, yeah, you could probably make your own show of playing music with robots, but beautiful robots, I guess, if that makes sense, like you said. Um, so
there,
yeah, yeah, go ahead.
no, I was like, there's actually work being done with this where there are people who are designing robots that interact with like performance art. There are artists that are using robots as collaborators and
Oh, wow.
creating pieces with them. And so I think that there's just this really amazing world
Kind
that's
of, yeah, kind of makes a new meaning to the like a one person band.
yeah, yeah. So you're now collaborating with these robots, right? And so from, one side you can think about like safety and you can think of it in like a mechanical kind of space where you're thinking about this in assembly or in manufacturing, but you can
Mhm.
also think about it in an artistic space where you are are collaborating with a robot and what are the results and what does that mean and what exactly is happening.
So are you talking about collaborating like with the AI or with just the
Uh,
mechanical, you
Both,
know?
right? And so I think it's just really kind of interesting and fascinating. Sometimes scary, but also I think it's something to think about. And the questions of ethics that are related to this, and
Yeah,
what does this mean for our society as we
yeah,
are advancing AI kind of technologies and the
yeah.
way we use robotic systems and whatnot. So um, I think that it brings up a lot of questions about.
Yeah, yeah. I mean, well, like you're talking about this more and more, but in the future, even music, you look at music now, I think, it used to be more acoustic or less, and it's become more and more computer. And I think it's easier, to make music now than it ever has been. And it sounds good. And so a lot of like older artists look down upon, the new music because it's easier. And, in the future, are there going to be as many, musicians, people in fact, that kind of links to people in factories getting pushed out because uh, there's robots are taking their positions. Um, so my mind's just thinking of a lot of things right now. But yeah, it reminds me when I was a PhD student, we were working on a senior design project with I think it was Gibson Guitar.
Oh, cool. Uh-huh.
It wasn't playing music, but they had they were trying to improve their manufacturing process, make it more modernize it. And but the issue was you had these people who had been doing this for years, like or decades, and just the artistry and making the guitar was very difficult to replicate.
Yep.
And they're kind of similar things here. Can you even replicate uh, the music or the feelings? And,
I think that these are really kind of interesting questions. I mean, going back to the former, I think, there's a question of what a robot does. Are we actually what type of jobs are we if a robot's taking over, what type of jobs are they taking over? You can think of modern times if they're just doing repetition, is that really a job, right? Or is they that they're adding value in the sense of the type of jobs that people can do as a consequence, right? And so I think there's this interplay and this discussion that needs to be happening with regards to that as well.
Yeah.
And
And
so,
talking about the collaboration, if you've ever tried using like a translator on Google, you type something in, you translate into one language from another language, then bring it back. You can kind of create new. I write a lot, so you can create new. It's kind of artificial creativity in a way because the words will change meanings as you go from language to language and you get new things. So I kind of see that with what you're talking about with the robots. If you might play something differently, but if you kind of go around, maybe is that what they're doing, something like that? Or
yeah, I mean, I think it depends, right? I mean, it's, I think going back to your original thought with regards to, or what I perceived as your question with regards to, you know, you lose some information when you make an algorithm for something,
right.
right? It's based on certain assumptions. And what you put in for the assumptions can make different kinds of results, right? And so, do you want to incorporate some type of noise into your system, right? To try to create this kind of art? Like, I don't know. I don't know the answers to that, but that's kind of, I don't know. And so
Yeah.
I think it's kind of interesting though. And do we want to know, right? And so that's kind of the way I think about those kinds of problems.
Are you using I guess it's getting more engineering now, but do you use like a closed loop? Because if you have does the robot feel or make measurements, or is it just?
So it depends, right? So there are some that have gloves that have like force, so you can figure those kinds of things out. Uh, I guess it depends on what you're asking. So for the body tracking and what we're doing right now, it's all just visual based. And so we have cameras set up, and we're trying to figure out how to model that. There's a lot of algorithms already, in existence, and so we're just trying to come up with our own method of doing it. I work at an undergraduate institution, so this is, I think, just a fun project for our
No, it's
students to
good.
work on. And so, so we mostly use like visual based systems, and using that to control other robots that we may create. But we haven't at this point taken information from the robot and feed it back, and to create this kind of a feedback kind of mechanism. That is something that I'm kind of interested in looking at, but we haven't gotten there yet. But I think
we'll have to keep in touch and see where it goes. I'm trying to find someone. It's because my area is friction, and so I've heard that like a violin, when the string has a resin on it that has a certain stickiness to it, you draw across the string. So I could see, even if you had the exact same robots, but if it was just doing the motion, and the instruments were a little bit different, you might get something different going on.
Right. And I think they're also, so we haven't, incorporated something like that, but the way you grip, right? So playing keys is, just a tapping kind of motion, where if you're, well, with the violin, you're not necessarily picking, but, you're kind of going across. And so the rate at which you do it, if there's the like traction or whatnot, that,
I mean, I could see, I don't know, maybe someone's done this, but like a musician, a human would correct maybe. Like if you give them one violin and they play something, and they give them a different one with slightly different, they might adjust their speed or something to make it sound a certain way. It's very interesting.
I think it's cool. I mean, kind of the way you get the feedback when you tune a guitar, right? And so you strum a few times, and you fix it for where you are. And so in the situation with a robotic hand, maybe you are not able to do it, or you yourself have to like fine tune the arm in order.
They have robotic tuners now, right? I think.
Yeah,
or
yeah, I've seen them, but I don't know
yeah, I've
too much
never,
about that.
um, I saw something else that kind of relates to that. It was something about if you're in your office and you had a camera and tracking your motion or writing on a chalkboard or something. Maybe I got that. I don't know. But my family got this Facetime Portal. It has a camera on it and it tracks your motion. So if people are in a room, it sounds kind of related to what you're looking at there too, because you're looking at the position and the motion.
Right. Yeah, and so, if you're trying to even like identify a human, right? So there are algorithms for object detection, right? So you can kind of go from human to individual joints and kind of go from there. But how do you do that, right? So I think it becomes a really interesting question because it depends on the way you put in what you're looking for into an algorithm as to how it works and how well it works. And it may work best in certain situations versus other situations. And so these are the kinds of thoughts and ideas that you have to kind of come up with and figure out how do you rate these different kinds
Yeah.
of ideas. And so I think it's really fascinating. And
Yeah.
how
Are
do the
they,
algorithms change when you re-rate? And so I think that this is something really kind of interesting to explore.
yeah, there's cameramen or camera person is that another job that might be in jeopardy if you have a robot controlling the camera angles, but you could adjust your algorithms to get a different feel, I guess, to the camera work or something. It really opens up a lot of interesting questions and kind of some ethics too, I think. Um,
I think that's really important. I think it's important for people to start having these discussions and trying to see, what happens when we have certain assumptions or we accept a certain kind of way of looking at things. And I've always been interested in writers because they sometimes think of these different kinds of modes, right? And then see what the outcomes are from those kinds of assumptions, right? And so trying to understand that, like, what does this imply for society? What are the outcomes of that? And I think that these are really, really important questions that we should be looking at and answering right now. I think that
yeah.
it's incredibly important.
What do you think the outcomes are going to be?
I don't know. I mean, I think that we're in a very, I mean, I guess every generation says that, but I think that we're in a very critical time, as we're having more surveillance, we're having more of these algorithms um, that are being created, and we're coming up with uh, different modes that are based on that, and so asking these questions and not being sidetracked or like not sidetracked, but shocked by the implications. And I think that these are some really serious questions to
Yeah.
ask and to explore. And I
I'm not
don't
sure
know.
if we want to go down this road, but Elon Musk, he's everywhere. But I think he said he believes we should worry about AI and machines taking over at some point, like Terminator. What do you think about that? Or do you have any?
I think that that's, I mean, I think in a certain sense, that's not the right question, right? It's more, I think that that could be possibly be an outcome, but what can we do to prevent that? Like, what are the set of rules that we need to come up with, right? Should we use like, um, what are the implications? What are we should be questioning everything we're creating in a certain sense and thinking about what the consequences are of what we're creating. And so, I don't know the answer.
Yeah.
I think for me personally, I think it's a really kind of important question. And this kind of goes back to um, my thoughts about this is not necessarily an engineering question or a math question or a science question. I think that these are questions that we need to bring in people from other fields and humanities, social sciences. And I think that these are really, really important questions and we should be looking at this as a society as a whole, and not just like engineers necessarily answering these questions. But I think that this is something that we should be asking from the general
Absolutely.
public. And
Yeah.
so I think that this is, we talk about, STEM became STEAM, but it's not necessarily just there. I think there are these other types of questions that we should be using their expertise to answer, because I don't know the answer. I haven't
Yeah.
thought about that enough. I'm concerned,
Yeah.
but I don't necessarily know I have the answer. And I think the best way is to reach out to people that
Yeah.
they may have the
Absolutely.
answer. And that's something that I really want to try to explore.
Yeah. Maybe that you're right. I mean, I could see if you just, this is thinking way out there, but if you had teaching, you have to teach the machine, I guess, right? That if you're talking about AI or machine learning, and if you teach it, the art and the humanity of it, making music, or maybe that would help figure out the problem, because then the machine would identify with humans more than,
Yeah,
I
I
don't
mean,
know.
I know sometimes I feel, in a certain sense, this becomes, kind of futuristic, but I do think at this point, this is something that's really important. I mean, what kind of systems do we want to create, right? We're creating them, right? So we, in a sense, do need to talk to people, and we do need to have an understanding of what we are creating. And so, I think that these are just really, really important questions, and questions that I ask a lot of people because I don't know the answers.
Yeah.
And so I just think it's really important for us to look at this.
Yeah. Yeah. You got to ask the question, I guess. Futurists, I guess, is people who really, things are usually not right. What I'm saying. So, but you got to answer, and you got to look in. Maybe that's because people have been looking at it, so they change what it does happen. Um, Going to math a little bit. Do there's a weird question maybe, but do you see, beauty in math, or?
No, of course. I think that there's really, really different areas of math, right? And I feel like um, it's how you create these links, and some of the links that you have to create proofs are really elegant and really creative and really beautiful. And sometimes you are reaching into these different kinds of areas to create these links. And I think that there's a lot of beauty with that, a lot of creativity. Um, and I just think it's really fascinating. I mean, uh, I sometimes joke I have a very limited toolbox, right? But I apply it into so many different areas. And I think that that's something that's just really fun and something that's really fascinating. I mean, you mentioned predator prey models and differential equations. And so you can look at differential equations and, a system um, that can model love relationships, could also
I
model
think
like,
there's a TV show on that now.
yeah. And so there's, but if you look at the equations, right, and you look at it, they two seemingly different areas can have the same kind of root
Oh,
equations. And I think that that's so fascinating, and
yeah.
it's so interesting how, in a sense, everything's so interconnected. And I think personally, I think that's really beautiful, and it's really, really fascinating. It's
Yeah. When
something
you
I love to
can,
do.
yeah, I find solving something mathematically. Yeah, there's definitely we call it a closed form
Closed form
solution.
solutions. Yeah.
Yeah,
And
that's
those are
beautiful.
my favorite. Yeah. I think coming up with a closed form solution, that's something that this is, I've, I've basically spent a lot of my career coming up with closed form solutions to open problems and calibration
That's
and
great. Yeah.
registration. And that's my area of expertise from a mathematical standpoint. And I've had a lot of people say, but they're iterative methods to do this. Why do you care so much for looking at
Yeah.
closed form? And I was like, but that's what I find beautiful, like being able to clean up these equations and put them in a certain form, and use other areas of different areas of mathematics to clean it up, right? And
Yeah.
and sometimes you can have different kinds of solutions depending on which path, like what kind of mathematics you apply to the
Right.
problem, and they
Huh.
could still both be closed form solutions, right? And then understanding the art between that, I think, is really
Yeah,
I
there is
just think
definitely an
it's
art
really
to it.
cool.
If someone actually watches this, I think we might need to clarify. So closed form solution would, well, maybe you should explain what's a closed form solution.
A closed form solution, the way I like to kind of simplify it is one that you have an answer, an explicit answer. You can figure it out paper and pencil, whereas an iterative solution is more of an algorithm that would search around for solutions and come up to one, but you may not necessarily know that it's the right answer. So you could come up with a solution, but it need not be necessarily the right solution.
Approximate, right?
It could be, it could not be.
Might not be.
Depends.
Yeah.
Yeah, it depends. And so this is one of the dangers of using iterative methods is that you can come up with solutions, but unless the problem has necessary and sufficient conditions for showing that that is indeed the true solution or
Yeah.
within a certain bound. And so this is something that I always kind of warn students that take classes with me. Just because a computer gives you an answer for a complicated problem doesn't necessarily mean it's the right answer.
Definitely,
And
yeah.
so I think that that's something that we have to be worried about, and we have to kind of, warn our students about that. These models are based on assumptions, and you have to check to make sure that your assumptions are being satisfied when you get an answer. And so questioning, what we get is, I think, something that's really important, and making sure that the models that you built and the assumptions that you put into it are relevant or satisfied once you get a solution. Um, so it's a similar thing with closed form solutions. Sometimes you can make a closed form solution. Yes, I did it with paper and pencil, but I may be making some assumptions along the way. And so making sure that those assumptions are indeed satisfied for your model is important.
Yeah, I agree completely. Engineers that we teach, there's a lot of good software out there, and it's real easy just to plug stuff in, get an answer. But there's a lot of ways to get the wrong answer.
Yeah,
It's probably easier to get the wrong answer than the right answer.
And I think that's why that's kind of what I push with mathematics. And I think questioning and making sure that you understand the answers that you get, and understanding, questioning the answers that you get, and making sure that it is actually solving what you want it to solve. And I think these are skills that engineers, why are they taking mathematics courses? To build up that intuition and to be able to build up that kind of the necessary tools in order to check these kinds of things, and the mathematical sophistication to understand the algorithms. And I think that that's incredibly important. And also phrasing the problems that they approach, right?
Yeah.
You have to put it into some kind of language, right? And I think that mathematics, in a certain sense, gives you that language.
Yeah, it's a kind of a universal language. Do you think the university is based on mathematics? Do you think we've created mathematics to, describe the universe or everything?
I think it's interesting. I mean, I don't have an answer for that. I think it gives us a language to try to interpret it, but that language is also fluid, right? It's based on the assumptions that you make, right? So
Yeah.
That's the way I look at it. I believe in universal truths from mathematics and basic axioms, but those are what you have to assume are true for everything to be built upon. So in a way, I think this also kind of goes back to this idea of beauty, that like you start off with these basic principles that you assume to be true, and you build up this whole world based on that. And I think that's so fascinating.
Yeah, it's very. I always had trouble with it, though. I was way back. I was a computer science major, and we had to take this class called algorithms, and it was all proofs, and I was terrible at terrible. I always had problem. You make assumptions, but which assumptions do you start with?
Yeah.
And I never knew, what is more fundamental, because you have all these different. Where's the starting point? I guess is was not good at figuring out.
But I think that's where the creativity comes in, right? And it depends, right? You could have two different proofs based on two different starting points, and I think that's so. I mean, when I'm grading like proof-based courses, and I
wish
see
you were teaching it when I took it, because that's not how I got graded. It had to be pretty much what he wanted.
No, I think that's where the creativity comes into play, and I think that there's so many different ways of answering it, right? As long as you're correctly following a sequence of logical steps that makes sense, right? You can come up with the same conclusion. And that's why a lot of times there's multiple proofs or types of proofs for the same problem. And it's where you decide to start from. And then, you kind of wind your way to a solution. And I think I just think that's really neat.
Yeah, it's amazing. So, you went to Rice at some point, I guess.
Yep.
But you actually grew up in Tifton, Georgia. Is that right?
Tifton, Georgia. Yep.
Because that's only like 2 hours from. So you probably heard of Auburn.
Yeah, of course.
Before that, yeah. So you must have had some, shift or changes in culture.
Yeah. Yeah.
Going from Tifton to Rice is probably kind of similar, maybe, but
and then Maryland,
and now New York.
And now I'm in New York City. Yeah.
So any observations on that?
There's a lot of observations about that, I think. Yeah, I mean, that's an interesting question.
If people don't know, Tifton is pretty small. It's not a very small town, but it's
a small town. Yeah, it's a small town in South Georgia. It's about an hour north of the Florida border. I say there's good people and there's good experiences everywhere. I've lived in, Tifton. I've lived in, bigger cities. Now I live in New York City. And so,
the sign was going as he said that.
Yeah, exactly.
Which you probably wouldn't hear in Tifton usually.
Probably not so much. I've enjoyed every place that I've lived. I think that, there's something to be said that there's great humans everywhere. And I've been fortunate to meet so many amazing people throughout each of these places that I've lived. And culture can be different, but people are good people everywhere. And it has been,
Well, you went that way because I talked to people going the other way or thinking about going the other way. And I think sometimes from like New York or maybe Midwest big cities, they're kind of scared of southern towns and sometimes, or have a different, I don't know. I think there's a little bit of a fear. There, like you said, there's bad and good, but I don't think it's as people are people. I agree.
I think that people are sometimes scared of being in New York City too, right?
Yeah, that is scary too. Yeah.
And I've fallen in love with New York City. I think it's an amazing place. And even though we're in the middle of this pandemic, there's still.
Did you guys shut down completely there?
Pretty much, yeah. Yeah, it was an interesting time.
Are you open? Are you on campus again? Or are you?
There's limited availability. So right now I'm on campus, but there is definitely limited kind of times that you can be on campus and whatnot.
Yeah, they're pushing to open things up here. Fall is planned to be in-person teaching, but we'll see.
Right.
Interesting times. I think we could spend a lot of time just talking about that, but I was thinking about people in cities. I think it was harder on them being like in quarantine. If you're in an apartment in a big city,
it was definitely challenging. There was no backyard to walk around, and we're fortunate we have a tiny little terrace, but there's you don't necessarily you can't.
In Auburn, you can, depending where you live, you can go outside and not see anyone.
Right.
Just go to nature, and
that's definitely something that was missing in the last year, or I guess more than a year at this point. But I'm very optimistic, as the vaccines are going through. And
are they going well there, or?
We just got to 30 and above, so I'm hoping that things get better.
Okay. Our county, Alabama, I guess, is last in vaccinations. I read that today. per population, but Lee County Auburn's in, I think, has actually done pretty well. We have a good hospital, and the university has gotten involved.
Right. I think that that helps, right? And if you have more densely populated places, right? So New York City, you know, there's so many vaccination places, and so I think that that's helping to increase.
Yeah, it's strange times. Hopefully,
Yeah.
we get all this figured out soon.
Yeah, but I don't know, it's been interesting.
Let's see. I don't know. Is there anything else you wanted to? We covered a lot of ground and a lot of interesting things.
Yeah, I don't know, unless you have questions for me.
You know, they talk about the predator prey. I don't know if people. I was introduced one of the. I don't know when it was. It might have been middle school, but this teacher. We were talking about programming and algorithms, and it was foxes and rabbits, and
That's the classical, yeah.
Yeah, and you're putting in how many the fox is consuming the rabbits when the rabbits aren't reproducing fast enough, and so then you get the like an oscillation. Yeah, but if it goes out of control, and but I'm sure you're getting kind of more elaborate.
We add more parameters to it. You know, you can add more systems to it, and so it becomes a really interesting model, right? So it basically assumes like exponential growth for the rabbits, right? And then you basically have a point where there's a lot of rabbits. So then what happens, right? The foxes start eating them, right? And so then the rabbits population goes down, but then there's not that many rabbits, so the foxes are hungry, so their population goes down. But once their population goes down, the rabbits are not being eaten, so their population goes up, and so it has this cyclical behavior, and that goes back and forth. And of course, this is based on very specific assumptions, and so you get these kinds of cyclical behaviors.
Is it harmonic?
In what sense?
Well, harmonic would be like sine, cosine, right? Or
yeah, exactly. So you can start to think about how to model these kinds of systems.
It's periodic, I guess. Sometimes does it ever?
So,
it goes unstable though, or can it? Go
it depends. It depends if you add extra assumptions to the space. So with a base predator prey, it's usually just like a kind of cyclical kind of orbit kind of thing. But you can add different kinds of parameters to that model to get different kinds of results. And so
it's very beautiful. And
yeah.
we're talking about that, you know, the mathematics, and we can kind of tie all this together because I was thinking about there's something called slip friction.
I don't know this.
Yeah. So, the area I'm in is tribology, friction, and this has to do with the violin. So you take the violin string and you bring it across, and I might be totally wrong, but I think this is right. So when it goes across, it might get stuck for a moment. And so this kind of is like the predator prey because the friction is larger than the force you're applying. So it's stopping it. And then your force overcomes it, and then the friction drops. So when it's sliding, the friction is lower. You might see this, you know, put your hand on a table. If you're moving it, the friction's lower probably, but if stationary, there's more friction than when you're moving. That's how it works. And so you get this stick-slip behavior that kind of has the up and down oscillation. So, you know, music and predator prey, maybe that's why you identify with all these cycles and these repeating. Maybe that's kind of yeah. Yeah. And then you do anything with like multi-scale, like spectrums or spectral, you start adding things up, you know, add it on, like in music, there's probably different scales of vibrations, and that's when you get more complexity.
I don't study that area, but I know that there's areas or people that do. I'm not an expert in that, so I can't speak too much about that.
All right, but this is a great discussion, and thank you for doing that. I guess we're in about 45 minutes, so that's pretty good.
All right.
Any other last minute thoughts or anything?
Yeah, this has been fun. Thank you. It was nice meeting you, and thanks for reaching out.
Yeah, thanks for doing it. It's really appreciate it. I'm gonna. Oh yeah, if you have any other, Cooper Union might be a good place to look. But if you have other suggestions for people who might fit like these kind of discussions, please let me know.
Okay, sounds great.
Because it's hard to find them. Maybe that's something to mention. I know people have common, engineers, scientists are interested in art, but then trying to find people that are really open about it, it's hard to find, or active about it, if that makes sense.
Well, there's quite a few here at Cooper, people that are very, very interested in these types of problems.
Yeah, so that's great.
Yeah.
All right, and I guess once things open up, if you ever want to visit Auburn, let me know.
No, that'd be great. Thank you.
And I don't know when I'll be in New York, but I'll let you know. But
yeah, reach out, please do. You can come see Cooper.
I've heard a lot about it. It's
a really amazing place. It's a really fascinating place.
I think they got a good idea that they're doing, so I think eventually things will be going that way everywhere probably.
Yeah.
All right.
Well, it was nice chatting.
Thank you.
Alrighty.
And I'll see you again sometime. Hopefully.
Okay. Sounds great. Thanks.
Thanks. Bye.